102. The Naked Scientist.
25 minutes to 3 o'clock. We get to end the show on a really fun and curious note. It's like Forrest Gump's box of chocolates because we just never know what we're going to get. So, your science questions right now to Dr. Chris Smith on 011-883-0702. We always get something. Sometimes we get too much, but we always welcome your calls. What science curiosities do you have today? So, Chris, my producer and I, Kabazela, were talking about when your leg dies, and I sometimes get it in the middle of the night. I get woken up by a dead leg or dead arm. And it's always just so disruptive. And I wonder, how does that happen? And then he said for him, he gets a dead leg when he's on the loo.
Oh, no. What's he doing on the loo? The phenomenon you're describing is actually caused by pressure being applied to a nerve. You have sensation in all parts of your body because of nerves. These are thin threads that bundle together to make big cables of nerves, which are like electrical wires. They send signals from your periphery, your skin, your muscles, your joints, deeper tissues, back to the spinal cord. And in the spinal cord, they're then transmitted on to the brain. And that's how the brain knows what it feels like in different parts of your body. But nerves are metabolically really active tissue. In other words, they're using a lot of energy to send these messages backwards and forwards along the nerves. And the way in which they get that energy is because around the nerves are small blood vessels. They're called vasa nervorum, blood vessels of the nerves. And these nourish the tissues around the nerve and also allow the nerve to continue to generate the kind of energy it needs to propagate nerve signals. If you fall asleep in a funny posture and you apply pressure directly onto a nerve, when you press on the nerve, you cause that particular area of the nerve to what's called depolarize. And that means it stops conducting impulses beyond that point. And this is because of direct pressure on the nerve and also because of interrupting the blood flow through the nerve. If this is just a short-term thing, and you don't do this for a really long time, then you get a temporary paralysis or loss of function of that nerve. And when it happens to a sensory nerve, you will feel that you get pins and needles. If it happens to a motor nerve, then you'll find that the muscle that the nerve normally controls doesn't respond properly. Most nerves are a mixture of both sensation and motor. And so you'll find that you're getting pins and needles and other funny sensations from the territory of your body that the nerve supplies, and also that the muscles that nerve supplies you're trying to move don't respond properly for a while. Normally, if you take the pressure off the nerve, and this happens when we go to sleep, because when we go to sleep, we tend to stay in one position for an extended period of time. So if you're laying a bit funny on one particular nerve, you might compress it for a while and make this happen. But normally, when you're moving around during the day, you don't press on any particular nerve for sufficiently long for this to happen. Now, what can happen, though, is if a person falls asleep and stays asleep or unconscious for a really long period of time pressing on a nerve, the damage can be irreversible. And there is something called Saturday night palsy, which is a classic injury to an arm where a person comes home having had a bit too much to drink. They fall asleep with their arm over the back of a chair. And as a result, the nerve under the arm is compressed against the bone in the arm, and it can cause irreversible damage to the nerve under certain circumstances. Some recovery might be possible, but not always, and people can then get paralysis and sensory changes in the affected arm as a result of that. So that's certainly a high price to pay for a Saturday night out. But the good news is that most of the time, when you start moving around again, or you take the pressure off the nerve, then it goes back to normal because the blood flow is restored, the pressure is relieved, the nerve repolarizes itself, and then it starts to transmit signals beyond the squeezed point again as
But
normal.
it's no fun. It's no fun. As that functionality returns, it's no fun.
It really hurts.
you
Yeah,
know,
it does.
does.
It's
It
because
does.
you then get a barrage of activity going up and down the nerve. And we actually did this for fun, partly at medical school. They actually did an experiment on us where they put a blood pressure cuff around our upper arms and pumped it up to higher than your blood pressure so that no blood would flow down your arm. And this deprives the nerves of their blood supply. And if you deprive them of their blood supply, eventually they run out of energy and then they stop conducting any information. So you can see the sensation or feel the sensation fail in your arm over time. And then you let the blood pressure cuff off and the blood flow returns, and then you can see how quickly the nerve responds and begins to send impulses again. And so I know all about those sorts of sensations because I've had them, and it's not nice.
Yes, you made yourself the research subject. Let's go to
Absolutely.
Nhlanhla in Soweto. Hello, Nhlanhla.
Hello, Azania, how are you?
Good and you?
I'm good. I've got a question for the naked scientist.
Yes.
It's a question that I've been asking myself for the rest of my life since I've been alive. Um, does he believe that extraterrestrials do exist, like aliens? Is planet Earth the only planet that has human beings, or there's other planets that have other people living in it, even if they are not called people?
Yes. Nhlanhla, do you believe there are?
I think so, because there's a lot of planets and a lot of galaxies. So
Okay.
it's possible for us to be alone.
Chris?
Yeah, I'm with you. I completely agree. The universe is so vast that numerically it seems inconceivable that it's just us. We are one planet around one star. There are something like 200 billion stars just in our galaxy, the Milky Way, and there are about 200 billion galaxies like the Milky Way out there in the universe. So that means the number of planets is absolutely enormous. If you've got 200 billion times 200 billion, you've got 22 zeros after the number, and then you've got all the planets around those potential stars. So the likelihood of there not being another planet Earth like place capable of supporting life with the same sort of chemistry that gave rise to life on Earth seems inconceivable to me. So I think on the basis of a numbers game, it's really very likely. But the question then becomes, well, how likely is it we'll ever meet them? Because the vastness of the universe is, whilst it's helpful in terms of there being likely life elsewhere, it's unhelpful in terms of those distances being so great that we may never get there, because some of these places may be beyond what we can see of the universe, and some of these places may just be so far away that with our present technology it is impossible to access them. So even though things travel at the speed of light, there are galaxies we know which are billions of light years away. So even if we could travel at the speed of light, it would take us billions of years to get to them, and life may not exist in that form by the time we got there. We certainly wouldn't. So I think it's very likely that ET does exist. It's much less likely that ET will come face to face with us anytime soon, which you could say that might be a benefit in some respects.
And it's ever expanding, so those distances are growing and growing and growing.
Well, that's true as well. Yeah, the universe is getting bigger, and the older it gets, the faster it grows.
Wow. Next, we go to Lindy in Midrand. Hi, Lindy.
Hi, Azza. I've managed to convince myself in the past few months that I'm convinced that we're not sleeping in the correct way, and I'd like the naked scientist to maybe just help me figuring out what proof do we have that sleeping on a bed, on a pillow, is actually the way we're supposed to sleep. I mean, going forward with like aging and so forth, like, is there any proof that we're actually sleeping right?
Well, Linda, you're quite right to highlight this, because, of course, we spend about a third of our lives asleep. It adds up over the average human lifetime to 25 years spent in bed. So we really ought to get this right, because it's very important to us. If we don't sleep, we're ill. If you deprive an animal of sleep, it can even die. And if you deprive a human for sleep for long enough, they go mad. So good quality sleep is really critical. And we know that the brain does all kinds of very important things when we go to sleep. That includes cleaning itself up. The brain walls itself off from the rest of the body when we're awake, chemically. And when we go to sleep, it opens up various channels. This is called the glymphatic system, and it flushes out all the accumulated rubbish from the day to refresh the brain, as well as doing other important tasks, probably concerned with memory consolidation and so on. So for our well-being, we need a good night's sleep. Now, there is no prescribed way to have a good night's sleep. It's what works for the individual. Some people will find that certain environments are much more conducive and relaxing for them to get into a good night's sleep than others. Some people need it to be really dark. Some people don't care. Some people prefer a lighter environment. Some people like 2 pillows. Some people like 1 pillow. The bottom line is, it's what works for you. And don't be afraid to try things. Find something that works. Find something that gives you the most restful, longest uninterrupted period of sleep, which should ideally be about 7 or 8 hours, as far as we can tell. It does drop a bit as we get older, and young individuals need a bit more sleep than older individuals, but it's what gives you, as the individual, the best night's sleep. And if that means booting your partner up because they snore, that might have to be the price that they pay so that you can get a good night's sleep. But everyone benefits from everyone else having a good night's sleep, because then everyone's in a much better mood the next day.
Yep, absolutely. Thank you for that, Lindy. Busi in Randburg. Hello, Busi.
Hi, Azza.
Hello.
I've got a follow-up question for Chris with regards to putting pressure on your nerves. So for the last couple of weeks, I've had a twitching cheek. I want to know what's causing that.
Oh, I've had this. The classic one is the eyelid, and you'll have this annoying, irritating twitch, and it feels like half your face is moving. And you're thinking every time you're trying to look at someone and talk to them, you can just feel this irritation, and it's like having an itch you can't scratch, and it keeps happening at the worst possible times. This is because there is excitability at the union between the nerve and the muscle. And this can be because the muscle itself is overexcitable, or that there are messages coming down the motor nerve that controls that muscle and turning it on inappropriately. And it's more likely to be irritation of the motor nerve. This is not harmful. There are very few conditions where this is a pathological thing. This is a natural thing. It just happens from time to time. It's only if it becomes widespread and affects lots of other muscles that one might start to worry about something like this. It happens to everybody from time to time. Different muscle groups can be affected. Usually it's caused by too much coffee, stress, sleep deprivation, those kind of things. So if you're finding you've got one of these things happening, ask yourself, am I stressed at the moment? Have I had too much caffeine in my diet? Have I become poorly rested, poorly slept, and become too stressed? This will exacerbate this kind of thing. The good news is it usually just goes away. If you worry about it, you'll make it happen more. If you don't worry about it and just ignore it, it'll just go away and stop happening after a day or so.
Thank you, Busi. Thank you for that question. Here's a voice note as well.
Good day, Dr. Chris and Azania. This morning it was reported that a previously unknown strain of the COVID-19 virus had been identified. It was said that this so-called B614G strain is 10 times more contagious than that of the known COVID-19 virus. Is this information correct? And if so, is the death rate due to this new strain higher? Thank you very much. It's Anonymous in Pretoria.
Okay. Yeah, this was reported on in our bulletin this morning.
Yeah, we've known a little while about the existence of this strain of the coronavirus. It's D614G, and that just refers to the fact that the virus has changed one genetic letter in its code, which is leading to the switch of one amino acid building block for another. And specifically, this switch is occurring in the spike on the outer coat of the virus. When the virus infects our cells, it does so by using these spikes, which stick out from the surface, to cling onto a specific target on our cells called the ACE2 receptor. And when they do that, it brings the coat of the virus very close to the outer surface of our cells, and that has the effect of causing the two to merge together so the virus can get into the cell. This change of this D614G seems to make the spike a bit more stable. And the result of that is that the virus may increase its infectivity a bit. The evidence we have that this is probably helping the virus to be fitter and spread better is that when we've got genome sequences from outbreaks of the virus all over the world, initially there were outbreaks caused by a whole range of different types of this virus. There are lots of different little subtypes going around. Quite quickly in all these populations, we've seen that this particular form then takes over, suggesting that when it happens or when it arrives in a population, it quite quickly outcompetes all the other viruses that are spreading around. Now, the people, reassuringly, who get infected with this particular mutant form of the virus don't necessarily get sicker, so it doesn't seem to be good at making people any iller or translating into a higher mortality rate for the individual, but it does appear to confer a fitness benefit on the virus, meaning the virus can spread more, it can get to more people more quickly, it therefore can cause more cases. So overall, there might be a higher mortality rate because there are more cases overall, but for the individual who catches it, it doesn't seem to be causing a higher rate of mortality or consequences in terms of them being unwell. So it's something that people are monitoring at the moment, but we haven't completely got to grips yet with the full consequences of this, but it's something we expect to happen. Viruses all mutate, all viruses change as they go, and they optimize themselves to spread in the best, fastest, most efficient way, and this is the coronavirus doing that.
All right. Next we go to Santon with Nimrod. Hi, Nimrod.
Hi, Azza. Azza, I want to ask the naked scientist. I've got an 8-year-old who will wake up in the middle of the night, come to our bedroom, who will tell her to jump in. She will jump in, but the following morning when I'll ask her, why did you come to our room at night? She said, I don't remember how I came in there.
I've done that. Yeah, it does happen. And the posh medical word for sleepwalking is somnambulism. And sometimes, kids do have a funny dream or something and they partially wake up, but not completely. They go for a little wander. Where do they like to wander to? Mum and dad's bed, because it's warm, it's cozy, and it's got people who love you there, so you go there. And normally, if you just usher them back to bed, they'll be absolutely fine. Sometimes it can be a sign that something's up if a child keeps on waking at night and keeps on seeking solace from mum and dad, because obviously that's not good for anybody if that keeps on happening. So if you find that the child is doing this a lot, there might be an underlying reason. Maybe they're not sleeping well, maybe they've got something on their mind. You might want to investigate that. But if it's just the odd time they do it, then just getting them and saying, come on, back to bed, and putting them back to bed usually works, and then the cycle is broken and it doesn't happen again. But if it keeps on happening, as I say, you might want to look into this and make sure that there's not something else going on that's upsetting them or causing them to be disturbed during their sleep.
Thank you for that one, Nimrod. And then we have another one via text that says, please ask the Naked Scientist about the space mining race. Would this alleviate the constraints on Earth's resources? But in the same breath, would us mining, say, something like the moon, adversely affect the Earth? This comes from Jay in Alberton.
Hi, Jay. Well, this has been talked about a lot. And the reason it's talked about a lot is that there are lots of resources out there off the planet that we could recover and bring back to the planet, including some things which are much more common in space but rarer on Earth. But there is no such thing as a free lunch. There's always a price to be paid. To go to a far-off part of our solar system, or even a near part of our solar system, needs enormous resources. To then recover resources from there and then get them back to Earth safely, that's a big headache as well. Very, very expensive. So what you're going for has to have some kind of simplicity to access, be very abundant where you're going for it, be very rare here on Earth. And that means it's financially worth doing something like this, because otherwise the ends just don't justify the means. In terms of risk to our own planet, well, there are some, of course. It's costly. Also, when you're sending your rockets off in the first place, there could be an accident, and that could be dangerous. When you're recovering the payload back to the Earth, again, that could be dangerous, not without risk. So there are always risks for anything that we do. One has to make an assessment and a judgment about whether those risks justify the ends or the lengths you're going to in order to do it. But people are certainly talking about this, and it's a very realistic prospect to go and find parts of the asteroid belt, the moon itself. There are various things on the moon that are more abundant than they are on Earth, and people don't mind if you mess up bits of the moon because there's nothing living there. So you're not going to bring organisms back to the Earth and contaminate the Earth. You're not going to destroy an environment other than the pristine lunar environment, and there's an ethical aspect to that. But one could argue that if we do this in a restricted area and we do it in an area that we don't think has any other value, then you could justify it on those grounds. But it's certainly an area that's being discussed, but at the moment is not actually currently being acted on.
Next, we have Andrew calling from Hammanskraal. Hi, Andrew.
Hello, Azza. Dr. Chris, hi. The average pulse rate for an adult male is 70 to 72 beats per minute, and that of an adult female is 78 to 82. What makes a difference, because they're both human?
Hi, Andrew. Well, the answer to this is, first of all, to say, well, why does the heart have the rate that it does? Your heart is a muscular bag, and what it does is to fill with blood that's coming from your veins into the heart, and then the heart squeezes, and as it squeezes, it raises the pressure inside the heart, and that pressure pushes blood out of the heart into your arteries, which then perfuse your body. Now, the bigger your heart is, the more blood it ejects with each beat, but the slower it has to beat, because if it takes longer to fill it up, but then you push more blood out with each beat, you're still pushing the right amount of blood out. You just don't have to beat so often. And this is why an athlete who is trained actually has a higher cardiac output, but a lower pulse rate than somebody who is unfit. Men, on average, are bigger than women, And because women are smaller, they have on average a slightly smaller heart. A smaller heart can fill more quickly with a smaller amount of blood. So the heart therefore achieves the cardiac output they need with, on average, a few more beats, but a slightly smaller volume. But if a woman trains and increases the stroke volume, the amount of blood her heart can eject, then actually her pulse rate will come down just like a man's would. And a trained woman will have a lower pulse rate, resting pulse rate, and fully active, peak heart rate than an untrained man.
Andrew, lovely question. Thank you so much. That's Andrew in Hammanskraal. Well, we talked about, dead leg or dead arm. That one of our WhatsApp says, I woke up one night with the hand sticking out under my pillow, knowing I'd fallen asleep alone. I nearly died outright. It took me a while to register that it was my own numb hand.
It does feel like that. I've rolled over in bed having slept on my arm and slapped myself in the face with my own hand. And it really hurts, but because you have no control over this errant hand, and the hand doesn't feel that you've slapped yourself, but you sure as hell felt yourself being slapped, and it also didn't feel like your own hand doing the slapping. It was a really weird experience. So I know exactly where he's coming from.
Chris, thank you very much. I was saying earlier on, I'm dying to do an experiment or two. So if there's anything that you think I should try, do let me know. I'd love to bring back results.
Well, we should do this, shouldn't we?
We
should come up with an experiment of the week for everyone to try during the program. Maybe we could start doing this. We could get some bits and pieces, and we'll do an experiment of the week. A bit of kitchen science for everybody to get involved with each week, and then people can call us up with their results.
Yeah, exactly. Then we can all talk about what we observed.
All right, let's do that.
Labs. Fantastic. Thank you, Chris.
All right, you take care. Take care then. Bye-bye.
That was Dr. Chris Smith. We're going to set that in motion, and hopefully you'll be able to do these things along with us. So many more of us at home, listening in while at home. We can do this stuff on the weekend. And then every Monday when we come back, we can always talk about it. So let's see how we can do this one. Turn the studio into a sort of science lab.